Okay, so now we discuss on how to determine heat transfer during combustion process. Okay, before that, some definition and terminologies on this. Okay, reactant. Reactant is basically the fuel and air, right? And product is the product of those reactant after combustion. Okay, during combustion process, what being released is actually heat, right? Q, chemical reaction due to combustion, and after that it produce Q, heat, and as well as the product. Okay, those Q that we need to calculate, right? That Q that we need to determine. Okay, in order for us to calculate, we need to have the temperatures of the reactant. For example, this one is 25 degrees C, the reactant of the fuel, and the temperature of the fuel, and the temperature of the air, as well as we need the temperature of the product as well. For example, let's say put it as 1500 Kelvin, right? So by all these temperatures, then we can calculate the at first the enthalpy before we go towards the Q, which is the heat transfer. Okay, enthalpy. Alright, enthalpy is calculated using this one. First is this one we call it as enthalpy of formation. Alright, this one you can determine this from table A26. Right. So let's take a look. Table A26. Okay, this one. So for carbon, hydrogen, nitrogen, oxygen, the enthalpy of formation is 0. But substance like methane, carbon dioxide, they have their own values. Okay, so this is what we call as the enthalpy of formation. Okay, next is this one, enthalpy at specified temperature. For example, let's say if you want to determine the enthalpy of oxygen, which is part of air, right? So we need to determine the enthalpy at 7 degrees C, which is at the specified temperature. This some books put it as HT, but no need, right? So you should understand. This is actually enthalpy at specified state, at any state, at any temperature given. Okay, specified temperature given. Okay, next is enthalpy of reference state. This one occurs, it's actually the enthalpy at 25 degrees C. Okay, alright. So that's how we calculate the enthalpy. Okay, next we determine Q up. Alright, Q up. So from the energy equation, E in equals to E out, right? So we have the Q in into the combustion chamber, work in, and then we have Q out and work out. Okay, and plus the what we call the energy due to the enthalpy of the chemical composition. For this one is R, which is reactant, which is for both fuel and air, right? And next is equals to QR and W out just now, plus the enthalpy of the chemical composition of the product, which is P. Okay, so for this case, CO2, H2O, or N2, right? So by balancing out this equation and cancel out the one that does not relate to our problems, for example, for this case, Okay, we don't have any Q in. Our problem, we don't have any Q in. Also work, there's no compressors or turbine here, so since there's no work, similarly there's no work out. What we have is actually only Q out, okay, which is heat that released from due to combustion process. So how we calculate this one is by subtracting the enthalpy of product with the enthalpy of reactant. Okay, so the unit is kilojoule per kilomole. Okay, so next we have another one, which is the enthalpy of combustion itself. Okay, so enthalpy of combustion just now is actually Q up, enthalpy up. Next is actually enthalpy of combustion. So how we calculate the enthalpy of combustion is actually equals to HP minus HR. Okay, so QC just now is Q out. QC is actually HC, which is the amount of heat transfer based on the enthalpy of combustion. Alright, so the unit also kilojoule per kilomole. So if you notice, both are similar but opposite. Okay, so you're gonna get similar value but opposite. Okay, so next is in order for you to calculate Q in terms of kilojoule per kilogram, so you need to divide the enthalpy with MF, which is the molar mass of the fuel. Okay. And also, if you want to calculate the rate of heat transfer, Q dot, so Q multiply with M dot fuel. This Q, kilojoule per kilogram multiply with the kilogram per second, so you're gonna get kilowatt. So this is valid for you for calculating Q out and QC. Alright. So okay, next we're gonna proceed with the example.